The world could soon run out of a crucial resource, and nobody's talking about it. Scientists work to solve phosphate shortage and the dwindling resource required to grow food. It's on the conversation. In a few years, by 2030, the world's population is projected to be about 2.5 billion people. Global food security is a major concern for governments. Zero hunger is the second most important of the United Nations Sustainable Development Goals. But there is a severe conflict between sustainable food production and the use of non-renewable resources in agricultural systems, particularly phosphate. Phosphorus is a major mineral nutrient required by crop plants for optimal growth and productivity. Phosphate is the only form of phosphorus that plants can absorb, and it often applies to crops as phosphate fertilizer. Phosphate is obtained through rock mining. 70% of the world's phosphate reserves are located in North Africa. China, Russia, South Africa, and the United States all have limited quantities of the mineral rock. Finite resources. Scientists have reported that global phosphate production could peak around 2030, and at the same time the global population will reach 2.5 billion people. Several reports have also warned that the global reserve would be depleted within the next 50 to 100 years. Current agricultural practice involves the use of a high amount of phosphate fertilizer in order to achieve optimal plant yield. This is because of the chemical properties of phosphate, which interacts with soil particles in a way that makes it difficult for the plant to acquire, leaving a large portion of the element in the soil surface. Because plants can only uptake small amounts of phosphate, a large majority of fertilizer ends up in unwanted places like bodies of water, making these particles ecologically and financially unsustainable, and it's only reasonable to fathom that the phosphate becomes more expensive and may eventually run out. It not only poses a food security threat, but may also pose political crisis between phosphate-rich countries and importing countries. Many researchers across the globe are committed to this effort, including the Global Institute of Food Security, GIFS for short, at the University of Saskatchewan in Canada. My doctoral research at GIFS investigates the role of mobile molecules in the integration of root and shoot growth under mineral deficiency conditions. The GIFS research team explores how molecules produced at one part of the plant, for example the shoot, modulates the plant's response to mineral stress at another part, like the root. Understanding phosphate absorption. A stitch in time saves 9, and it's with this in mind that researchers across multiple disciplines are looking for ways to optimize phosphate use in crop plants. Soil scientists seek ways to improve the soil phosphate management, while plant biologists have intensified their efforts in understanding how plant can absorb too limited phosphorus. Indeed, considerable achievements have been made in understanding plant adaptive response to low phosphate in soil. For example, when plants are starved of phosphate, they stop the growth of their primary root and grow more secondary roots and root hairs in order to increase their ability to absorb phosphate in soil with lower levels of the mineral. This strategy that is referred to as changes in root system architecture. Another strategy is that during low phosphate conditions, plants are able to remobilize storage phosphate to other parts of the plant in order to maintain growth and development. During this period, too, plants change their gene expression pattern in order to adopt. They increase the expression of genes that are involved in phosphate uptake from the soil. In other words, more effort is committed to looking for and acquiring phosphate. And interestingly, advancement in genomics and biochemistry have helped us to overcome some of the genes and proteins that control these processes. But some regulatory genes that control plant response to low phosphate are still unknown, making it difficult to breed crops that are well adapted to low amount of phosphate. Protein regulation. This month, a discovery was reported in the journal Plant Physiology. An international team of scientists discovered a protein in plants that's able to sense phosphorus levels in the soil and then tells the plant to adjust growth and flowering. The protein, called SPX4, regulates the genes that control phosphorus uptake, plant growth, and flowering time. It tells the plant when it has acquired enough phosphorus and coordinates with the root to stop uptake. This discovery about how a protein integrates nutrient status with development will help us to understand how plants can perform well even with limited phosphorus application. Another research published by the journal Cell identified a gene that regulates root system architecture, and researchers show that this gene modulates the plant hormone, ultimately regulating the depth of the root system. And although this research does not directly involve phosphate, a better understanding of the root development will also help in the quest for developing crop varieties that have better adaptation to low phosphate. Considering the problem at hand and the advancements in technology, it's an exciting time to study phosphate signaling in plants and develop crops that can better adapt to low phosphate, and this will ultimately help us to produce enough food for growing the population without having an adverse effect on the environment. Government and funding agencies should support more fundamental and applied research that seek to understand how plants behave under low phosphate conditions. Now, as the world is dealing with a lot, right now climate rapidly warming, oceans growing dangerously acidic, a sixth extinction is officially unfolding, and while the threat of nuclear war hangs imminent, there's another crisis on the horizon we never heard of. The global cause catastrophe for the next generation, phosphorus, the essential mineral for all plants and animals on Earth, and that includes humans. It's a building block for DNA, and this basic resource allows living cells to transfer energy, and when it's mined from phosphate ore, it can be added to fertilizers to increase agricultural production. Phosphorus is not a renewable element, and there are currently no known substitutes in very few areas in which it's mined. As the world chews through even greater amounts, our dwindling supply of this raw material grows even more pressing. A group of 40 international experts has now warned that if nothing is done to conserve this crucial element, our planet might soon run out completely. In the past 50 years alone, phosphorus fertilizer increased 5 times, and with human population continuing to boom, demand is expected to double by 2050. As we race towards the brink, scientists from industries, universities, and research institutes say the world is entirely unprepared for the looming phosphorus crisis. There is no collaboration or coordination on a global scale that takes the responsibility of governing the global P resource, P meaning phosphorus, not even between EU member states or the states of the United States, says ecologist Casper Reitzel, who studies phosphorus in aquatic ecosystems and helped write the recent report. Quote, the EU Water Framework Directives, or the American Clean Water Act, focus predominantly on the ecological quality of water and do not integrate phosphorus sustainability to a sufficient level. At current consumption levels, some models suggest it will run out of known phosphorus reserves in 80 years. More conservative estimates place day zero 400 years from now, while others give us less than 40 years to come up with a solution to this imminent problem. Almost all the studies agree that this is an imminent issue in need of more research. And while cutting back our consumption will no doubt be key in fixing the issue, so will learning how to recycle phosphorus, and both will be especially impactful in developing countries. While the United States was once the leading phosphorus producer globally 30 years ago, India and China now account for over 45% of the world's total consumption. In all that time, our practices for mining and consuming this mineral have barely improved. Today, phosphate-enriched chemical mixtures are added to nutrient-starved soils only once before they are swept out to sea. Not only does this pollute oceans and waterways, creating dead zones where fish cannot live and poisoning drinking water, but it's also unsustainable. By putting together a closed-loop recycling system, researchers say phosphate could be reused approximately 46 times as fuel, fertilizer, or food, whatever we might need. Our current poor management of this essential nutrient represents a pressing challenge which caused global-scale pollution of water resources while failing to achieve equitable access to fertilizers to support food production worldwide, the group of international phosphorus experts write in a recent report. And where present, existing regulations that consider phosphorus are dated and fail to address sufficiently the wider aspects of sustainable use, or future needs to support equitable access to resources globally, they said. In response to years of inactions, the authors are urging industries and global authorities to develop a new generation of nutrient sustainability professionals who can work together to secure international phosphorus management and a clean environment for the rest of the world. These people should not be simple phosphorus specialists, but rather system thinkers who can inform judicious decision-making on all aspects of the management of phosphorus. As Reitzel, feeding billions of new mouths in the coming decades is going to be a huge challenge, made only more difficult when phosphorus stores begin to dwindle. There are many crucial resources we humans cannot live without, but there are few as irreplaceable as this one. Phosphate expert Marissa de Boer recently told The Guardian the lack of public awareness makes this issue the unknown environmental crisis. We really depend on phosphorus, but we take it for granted, she said. It's looking like we won't be able to do so for much longer. These findings were published in the Environmental Science and Technology, and this is on Science Alert and also on The Conversation, University of Saskatchewan, Canada, by Tu Louise Ulaka-Yodu, PhD student, University of Saskatchewan. If you'd like to join me on my Patreon account, you will hear content not covered by mainstream media. These riveting stories will be based on my research, and I will state my opinions and give my personal insight on diverse and controversial subjects and world events not covered by mainstream media, and not supported by YouTube guidelines. So whatever I have on my Patreon, most of those will not be on my YouTube channel. Please consider becoming a member today. More of the most significant and important videos will be on my Patreon channel. Your support helps me to continue my research and keeps this YouTube channel alive. And we depend on your support, your generous charity, because we help economically challenged families here in Athens, Greece, in Kapota, and we also help the young generation with university tuition and the community around our church. Thank you.